As always, we will let A be an n by n matrix. And we will let M, capital M, sub ij be the n minus 1 times n minus 1 submatrix. And again, these definitions are more for formal purposes. Once we actually do examples, anything that seems a little strange and unusual here will make a lot more sense. Of A obtained by deleting the ith row and jth column. Now let's see, so let A be an n by n matrix, let M sub ij be the n minus 1 by n minus 1 submatrix of A obtained by deleting the ith row and the jth column. Now the determinant of this M sub ij is called the minor of the entry A sub ij. So for example, if we had A sub 3, 2, that would be the third column, second entry. We would knock out that row and that column. We would take the determinant of what was left over, and then that's called the minor of that particular entry. And again, we'll do an example and it'll make more sense. One more definition. The cofactor of A sub I, let me put an I there, of ij, which we denote capital A sub ij. So cofactor, we use the capital. Minor, we use the M. Is the following. A sub ij equals -1 raised to the power of I plus j times the determinant of M sub ij. Okay, don't let all these subscripts and i's and j's and -1s scare you. Let's do an example and it'll make a lot of sense. So let's define our matrix A over here. We'll have 3, -1, and 2. We'll have 4, 5, 6, and the third row will be, oops, excuse me. We'll do 7, 1, 2. Now, M12, so M12, this is the submatrix that we get from crossing out the first row, second column. So if I knock out first row, second column, I'm left with 4, 6, 7, and 2. So we have 4, 6, 7, and 2. And that's exactly what it is. That's all this means. First row, second column, go back to the original matrix, cross out, and the numbers that you have left over, those form the submatrix, in this case 2 by 2, because the original was 3 by 3, so it becomes, remember, up the definition n minus 1 by n minus 1, 3 by 3 becomes a 2 by 2. Now, if we take the determinant of this M12, and again, the determinant of a 2 by 2 matrix is just, let me put some parentheses, is just that times that minus that times that. So it's 2 times 4 is 8, minus 42. What we end up with is minus 34. So let's put that aside for a second. So we have the minor, we have the determinant of the minor, and then we have that other thing that we defined, which is the cofactor. Well, the cofactor of 1, 2 is -1, and the power that you raise it to is the sum of this 1, 2 right here. So it's 1 plus 2 times the determinant that we got, M12. Now, minus 1 to the third power is minus 1. So it's minus 1 times, and the determinant we found already, which is minus 34. So our cofactor is 34. So let's go through this again. We have a matrix, we have a minor, we have the determinant of that minor, and we have something called the cofactor. So our matrix, this is our original matrix right here. Let me actually use, so this is our original matrix. We decided to take the minor, the M12, which means cross out the first row, the second column. So we crossed out the first row, the second column. What we were left with was a 2 by 2. That's our minor. It is a matrix. When we take the determinant of that minor, we actually end up getting this number right here. So this is a number. When you take a determinant, remember a determinant actually gives you back a number. And then what we do is we find the cofactor. The cofactor 1, 2 is the determinant that we got multiplied by negative 1 raised to the power of the sum of the indices, 1 plus 2. Let's do another example. Let me go back to my, actually let me go back to blue ink here. So let's see. This time let's calculate the M23 minor. So when we go back to our original matrix and we knock out the second row and third column, what we end up with is another, the 2 by 2, which is 3, negative 1, 7, and 1. When we take the determinant of M23, it is going to be 3 times 1 minus 1 times 7, which is going to equal 3 minus 7, which is 3 plus 7. We get 10, so that's our determinant. And now our cofactor, A23, that's equal to negative 1, and raised to the power of 2 plus 3, the row plus the column, times our determinant. I'll just go ahead and put that here. Okay, minus 1 raised to the 5th power is minus 1, so you end up with minus 10. So once again, we have our matrix, the original matrix. We knock out the second row and third column because we're interested in the M23. And we have a matrix. We take the determinant of that matrix, and then from that, we derive something called the cofactor. So it's the cofactor that's actually going to be the real important thing that we continue to deal with. Okay. So now that we have this thing called a cofactor, as it turns out, we can use it to evaluate determinants. So before, what we did is we used the properties of the determinants to manipulate the matrix, find as many zeros as we can, maybe factor out some numbers, simplify things as much as possible, essentially put it into upper triangular form, if you remember from the last lesson, and then just multiply everything along the main diagonal. Well, this is another method of actually doing it. And again, computationally it may not be as efficient. It may or it may not. It depends on the situation. But theoretically it comes in very, very handy. And it'll make more sense as we proceed with linear algebra. But for right now, let's just go ahead and work on actually finding a determinant using this cofactor expansion.